Hi, everybody. So I've decided to try something a little bit different with the notes this time. I am screen recording me writing the notes, and that's what you see in the large picture. And then me down here in the corner, just so that if I talk about something that is more of a visual, or I'm talking about something for a minute, that you'll see me instead of just hearing me. We'll see. Anyway, so this is notes 1A. This is the beginning of Matter Matters. So we're going to talk about what is matter and why does it matter. So everything in the world is made up of something, and we call this stuff matter. So matter is anything that has mass. So it has stuff in it. It has atoms in it. It has mass. It has any kind of weight. And it has volume. It means it takes up space. So looking at our Twinkies here, because you're seeing them right in front of you, right? So maybe you can't read it very well. I'm hoping maybe it doesn't look too bad on my screen. So hopefully it looks all right for you. But this is the ingredients from a box of Twinkies. Now, this is from a box of Twinkies from before. I can't guarantee that it's the same anymore, because I don't know whether y'all remember that there was a while there that Twinkies were shut down. You couldn't find them. But here we go. I'm going to read it. Ingredients: enriched bleached wheat flour. Flour, ferrous sulfate, B vitamins, niacin, thiamine, mononitrate, B1, riboflavin, B2, folic acid, sugar, corn syrup, water, high fructose corn syrup, partially hydrogenated vegetable shortening, contains one or more of soybean, canola, or palm oil, dextrose, whole eggs, contains 2% or less of modified cornstarch, cellulose gum, whey, leavenings, sodium acid pyrophosphate, baking soda, monocalcium phosphate, salt, cornstarch, corn flour, corn dextrins, mono and diglycerides, polysorbate 60, soy lecithin, natural and artificial colors, soy protein isolate, sodium stearocyl lactylate, sodium and calcium caseinate, calcium sulfate, sorbic acid to retain freshness. Excuse me. Woo. Coffee went down the wrong way. Color added: yellow 5, red 40, may contain peanuts or traces of peanuts. So that's the list of ingredients. So then you ask yourself, are Twinkies a kind of matter? So no matter what the object is, you can ask yourself these two questions. And if you say yes to both questions, it's matter. If you say no to either of them, then it's not matter. So does whatever the object is have mass? That's the first thing you're going to ask. Well, we're talking about Twinkies. So do Twinkies have mass? So do they have stuff in them? Yes. Do Twinkies have volume? Do they take up space? Yes. So that means that Twinkies are indeed matter. All right, so I want you to look at this list right here. And I realize that if you're doing this digitally, you won't be able to write on it. So if you're doing this digitally, I ask that you just put an X in front of the items that are not matter and put a 0 or a letter O next to the ones that you think are matter. So cross it off if it's not matter, X it if it's not, put an X over it if it's not, and put a circle next to it if it is matter. So pause the video and do that. Look through all of them. Make your guesses. Okay, so now let's talk about it. We got rocks. Do they have mass? Do they take up space? Yes. So they are matter. Trees. Yes, they have mass. They take up space. Love. Well, love certainly takes up space, doesn't it? But it doesn't have any mass. So it is not matter. People, right? You and me, we are matter. Cars have mass, take up space. Souls, again, might take up space, but no mass, so not considered to be matter. Notebooks, yes, that's matter. Has mass, takes up space. Anger. Okay, we're going to pause on that one for a second. Normally, this would be where I have this black stool that I bring out, and my students are like, "Oh, it's time for a life lesson with Miss Harris," and that's what this is. This is the second life lesson with Miss Harris. So the first one was the video about Richie Parker, and the second one is right here and now. Anger is definitely something that takes up space. It does. It takes up space in your brain. So does hunger. So does love. So does fear. All of those things do. So you have a space in your brain. It's, right. I can't point to it really because it's inside there, but it's about right there, but inside, way in the middle, like right there. If you were to draw a line between here and there, it's right there, right at the base of your brain. And it's the space that every message that your body is sending and receiving goes through. And it's only about that big, like 1.5 inches diameter. That's it. That is all the space for your heartbeat, your breathing, your digestion, your 2 + 2, your who loves me, all of it has to fit through that space. So you can imagine, do you have to think about breathe in, breathe out, breathe in, breathe out? No. But think about it, when you're real mad, what happens to your heart rate? Think about it. When you're real sad, what happens to your digestion? Right? So that's just it. If you're hungry, can you learn? No, because that whole area is filled up with I'm hungry. And you can't get any 2 + 2 through there. So anger definitely takes up space. It takes up space in your brain. When you are mad, that area inside your brain fills up and no messages are getting through. But that doesn't mean that there isn't something to be done about it. So if that's what's happening, well, what things open that space back up? All of us are different, but taking deep breaths should help everybody. In through the nose, out through the mouth, at least 3 of them. Do that a couple of times. Some people counting backwards from 10, counting backwards from 50, counting up to 25, whatever works. Some people just need to cry. Just need to cry it out, and then I'll be better. Some people need to go talk to somebody. Hey, I've got this thing going on in my head, and I can't. So what's the point of this life lesson with Ms. Harris? Mainly, it's so that when you get back into school and you're having a day when that area in your brain is stuffed full, be it because you've got stuff going on at home, be it because you've got stuff going on at school, be whatever. Communicating with me is really important because I'm not going to know that that's going on with you unless you tell me. And then I'm going to be expecting you to do 2 + 2. I'm going to be expecting you to do science. And you're not in a place where you've got any room in your brain for science. Learning to communicate, recognizing when you're getting close to those feelings, and then learning to communicate them to the people that are around you that are expecting you to interact with them. Major life lesson with Ms. Harris. It'll really help you. You've got to be more aware of what's going on in your brain and then making sure you can vocalize that to the people around you. Okay. Life lesson with Ms. Harris over. Moving on. So anger is not matter. It does matter. Love matters. They do both take up space, but it is not matter. How about your mom? Right? I'm a mom. Am I matter? Yes. Air. Now, this is a tricky one. A lot of people end up saying, no, it's not matter because they can't see it. They can't feel it. But wouldn't you know if there was no air in the room you're in right now? Yeah. It has mass. It's a small mass, but it does have mass. It takes up space. In fact, it takes up all of the space. It fills up the whole room. It fills up your lungs. But it is so tiny but it's definitely matter. Okay. Air is matter. Air is made up of oxygen, tiny little particles of oxygen, which we breathe in. We gotta have it. What did I just breathe in? Matter. Little teeny bits of it. Pizza, definitely matter. Sadness, same thing, right? Takes up a huge amount in your brain. I know a person whose husband was killed very suddenly, and she stopped eating because the message couldn't go from her stomach to her head. Hey, eat something. She was so sad that it just all shut down. It's definitely real. Sadness definitely takes up space, but it is not matter. So everything in the universe that we can see and feel is made up of matter. So if you can touch it, if you can feel it, even air we can feel, right? When you move your hand through I can feel the air. I can feel it rushing over the little hairs on my arms. I can feel it. Do you think that there's just one kind of matter in the universe or many kinds? All right, so this is open-ended. You're going to write on there whatever you want to. Do you think there's just one kind or many kinds? And then explain your answer. When you're done with that, I want you to read the ingredients list. Go back up to the ingredients list for the Twinkies and pick 3 things that you recognize. So if you need to, you can go back in the video and listen to me reading and just write down 3 things that you hear, or scroll back up to the top of your document and write down 3 things. Pause the video while you're doing that so you don't miss anything. So just like Twinkies are made up of many different ingredients, everything in the universe is made up of different kinds of matter. The periodic table of elements is a list of all the different kinds of matter that scientists have discovered in the universe. And we can think of them as the ingredients of the universe. So that should look pretty familiar to you. That's a periodic table of the elements. And it is an incomplete one. They have managed to fill the whole rest of the thing in. I have it over there on my wall. You probably can barely see it, but I do have all of them up there on my periodic table. Now, you couldn't walk up to a scientist and say to them, hey, what's your favorite ingredient of the universe? They look at you funny, right? So we call them elements. So you would say, hey, scientist, what's your favorite element? So each element has its own special symbol. So I want you to think of which ones do you know already? What are the elements that you already know the symbols for? Right? Let's see. Can you guess what any of the symbols mean? That's kind of what I just asked. Anyway, sugar isn't up there. If you look at that periodic table that's right above where we're writing, sugar's not on there. Why not? Exactly. Sugar is a compound. It's made up of multiple elements. So what elements make it up? Remember what our formula was. C6H12O6. So C, carbon, H, hydrogen, O, oxygen. Most things that we see in the world are made up of a combination of different elements, like sugar being made up of carbon, hydrogen, and oxygen, water made up of hydrogen and oxygen, carbon dioxide being carbon and oxygen. However, some things are pure elements. Things like wedding bands. A lot of times a plain wedding band is just gold and there isn't any other stuff in there. Does anybody know what the symbol is for gold? Oh, one of you knew. That's right, AU. Now, why is it AU and not GO? Because all of the elements, or many of the elements, are named from the Latin name for the object. So gold in Latin is aurum. So gold in the periodic table is AU. So that's where that comes from. All right, what about a penny? What element? And then the pennies now have a zinc core and are not pure elements. But old pennies before 1983, 84, 85, those are pure, that's right, copper. All right, do you know what the symbol is? Oh, I heard it way back there in the back. Anyway, I got to do something, right? Copper is Cu, and that, again, is because of the Latin. I can never remember. It's like Capernium or something, cuprous. I know it's called cuprous oxide when it's copper oxide. So cupernium is my guess. But anyway. All right, so aluminum foil would also be something that's made of only one element. So aluminum foil, when you go and buy a thing of tin foil, it's not tin, it's aluminum. And it's pure aluminum. There's no other elements in it. So if y'all were in class, I would have y'all do this. I would hand out pieces of aluminum foil and give you scissors and tell you to go to town. And what I want you to do is cut, and you can do this at home. Ask mom, can I have a piece of aluminum foil? And you don't need a very big piece. I mean, honestly, this is too big for what I need it for. So the first thing you're going to do is cut it in half. And then you're going to take the half that you have left and cut that in half. And then you're going to take that and cut it in half. And then you're going to take that and cut it in half. And again. 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 Okay, you see what I'm doing here? I'm cutting it by half and by half and by half and by half until I have a tiny little piece. And then I would have said, okay, once you think you've gotten the smallest piece you can possibly get, bring it up here and put it under the document camera. And I would have had some people that had some pieces that were about that big. Can you even see it? A tiny little thing. Hopefully you can see it. Now, even that tiny little speck of aluminum foil has more atoms in it, more aluminum atoms in it than you can even begin to imagine. So where did we get this word atom? There was this guy named Democritus, and he was an ancient Greek philosopher. Now, he was a scientist, but because science wasn't really established, science was more philosophical because we couldn't see the things that we can see now with all of the technology that we have. So he was kind of a philosopher, but he was a scientist. And he believed that if you took anything in the universe, a rock, a person, a bird, and you cut it in half and in half and in half, or even pure substances, in half and half and half and half and half and half, and eventually you would get to a particle that was so small that if you continued cutting it, you would no longer have that object anymore. And he called this particle atomos because atomos is uncuttable in Greek. So he's the one that gave us the name for the atom. Like that's where the name for atom comes from, this uncuttable particle. So even in my amazingly small little piece of aluminum foil, there are thousands, if not millions of aluminum atoms in that tiny little thing. If I could cut and cut and cut and cut smaller than this, I would have to keep going for a ways. Eventually, I would get to a single aluminum atom. And at that point, if I split that, not only am I going to have a big boom, because when you split atoms, that's what happens, but I also would no longer have aluminum. I would have separate protons, neutrons, and electrons, and it would no longer be an atom of aluminum. So what is that uncuttable particle? It's an atom. It's the smallest possible particle of a substance and still be that substance. Okay, that's it for today's notes. Thanks for joining me. Bye.